Okay, I'm recording now, for real. Um, is everybody able to see my screen? I noticed that Bob was unable to unable to see what was going on.
Hey Kyle, this is Rob.
Oh,
Uh,
Rob, sorry. It's
no, you were right. It's Bob from Casensum that was having trouble seeing your screen. I
oh
think,
oh
and I think he's been experimenting and still having trouble. But I was
okay.
just about to ask if you were recording. So as long as
Yes.
you're recording, he can come back and look at it later.
Well, yeah. I'm recording now. So
Okay.
okay, I think it is a Mac OS 10.13
Yeah,
kernel.
this is Bob. I'll just follow along in the source code, but I have no screen. And I think it's just I'm running it on two Macs and neither of them work, and I think it's a 1013 problem.
Oh yeah. Um, we uh, we uh, we know from experience that Mac users and Skype don't always get along. So, okay. So yeah, we are going to talk about the Voltron life cycle. Um, excuse me. We're going to talk about the Voltron agent life cycle. Um, and I had a chance. Okay, and my font is probably way too small for anybody to read, so give me one moment and we'll get that sorted out. Let's see, VIP.
Hey, and Kyle, if you can occasionally mention method names or line numbers in the file you're in, that would help me.
Yeah. I've got to find. I'm looking for a specific file here. So
Okay, thanks.
it's in. So I'm in. I'm. I'll just so you know, I'm looking in Voltron platform VIP. Oh, is it Agent Core? Yeah, there it is. Agent and then Core. So um, that function is, or that function, that module is the core, um, is the main part of the agent around which the entire all agent behavior um, wraps around. So let me change my font size here. Edit. Let's see, file. Where is it? Settings. There we are. Show only monospaced fonts. Let's make this 20. There we go. Apply that. Much better. Okay. Okay. Is this big enough for people to read? Um,
Certainly works for me, Kyle. It's
okay.
big enough.
All right. Scheduled events. And I'm just scanning here. I want to figure out where I want to start. Okay, so this is the basic core. And let me make sure. Okay, so that's right. Core inherits from basic core. I'm just getting my bearings here. Okay. Yeah, and then the different loop function. All right. So, um, okay. So just to so on line 95, you'll see the periodic class. All this class is for is maintaining state and handling the calling of periodic functions. So if you ever want to look at the machinery for that, it's in class periodic. Line 143 is scheduled event, which is a wrapper for uh, a scheduled function call that allows you to cancel that function call later. Um, so that's the machinery for that. But we're not going to get bogged down in these because there's just it, that's just what they're there for. When we go to look, eventually we'll get to the code where you actually use to set up the periodic, and you can see how it's actually used. We're not going to worry about find signal. Okay, so the life cycle of an agent is handled by the basic core. The basic core handles the is the main event handling loop for an agent. And let's see, subsystems. Okay, we'll get into the subsystems here in a little bit, but because there's lots of pieces that work together, and so I'm going to try and stay on track just talking about core, and then we'll jump around. And if you have any questions, just jump in and ask, because it's a lot to take in. So we're going to start at line 145 in core.py, or 175, excuse me, in core.py in basic core. The basic core also does some bookkeeping to keep track of like spawned greenlets, so that to make sure that they get cleaned up properly when an agent shuts down. If you use so you are free to spawn greenlets in your agent, but if you do not use the methods that we provide, then you're responsible for making sure that they get cleaned up. Or if you know that they're not going to run for very long, they should just go away on their own. But it's a good idea to use our interface for creating greenlets so that the bookkeeping is done automatically. The basic core, oh, and this is an important part. These are G event signals, and those should look familiar on setup, on start, on stop, and on finish. Those are the 4 different events in an agent lifecycle that you can bind to at different that get fired at different points during agent startup and during agent shutdown. So when you decorate an agent method with as an on setup method, then when the on setup signal gets triggered, that method will fire. That's what actually causes that method to fire, and we will see that in the code where on setup gets turned on. Let's see, are greenlets raised by periodic and scheduled events examples of things that would be in? Yes. When you call self core periodic in your agent, it creates an instance of the periodic class, and let's see. And in one case, let's see, the periodic function is spawned in a greenlet. Let's see. Let me check. Let me verify that. Oh no, that's right. The periodic loop, the loop on the periodic class is spawned in a greenlet that is one of those greenlets that will be managed by our spawned greenlets. So you don't have to. So if you create the periodic function through our method, that class is what gets used to manage it. You don't actually have to worry about it, other than this class instance. The periodic class instance is what is actually returned. Let's see. Let's see. No, I misspoke. The green, when you create a periodic function call, that returns the greenlet that periodic is running in. So you can kill it using the normal greenlet methods, but it does get added to the set of spawned greenlets. But you don't have to worry about that. That's an implementation detail that the base agent handles for you. Okay.
Kyle, a related question to that. If
Sure.
I'm running my own method under the periodic,
Yes.
and I'm getting stuff from a web service. In a
Yes.
prior discussion, you said that I should be using G requests as opposed to requests directly
Yes.
because right? Is that the recommendation?
Yes. Absolutely.
Okay,
Yeah.
thank you.
Um, that's so whatever, so that everybody knows what we're talking about. G requests is um, uh, G requests is a wrapper around requests that makes requests uh, friendly or cooperative is the word with uh, other greenlets in G event. And what I mean by that is if it's not cooperative, then if something blocks for I/O, like say you're doing a web request, if you just use requests, it blocks the execution of your entire agent. If you use G requests, while it's doing the I/O for the requests method, it does not block. Um, and so if you're doing like a periodic that's doing if you're doing a periodic that's doing a web request, if you use just plain requests and you try and kill that periodic, if you try, well, your kill won't get called until that request returns because it's going to block the execution of all of their code. But if you use G requests, because it becomes cooperative, you can kill the periodic function in the middle of doing that web request. And so if that web request is stalled out for 10 seconds, it's not going to wait until the request returns before the agent can resume execution. It'll just kill the greenlet immediately and shut the whole thing down. Yeah. So let's see. So setup in this case, let's see. The basic setup sets up our periodic functions. So that's the other thing is we use in our main G event loop, we keep track of whether or not there are any periodic functions that need to be called. And we sort the periodic functions in a heap, which is a particular type of data structure that comes within the Python standard library. It's a special use of a list. And it keeps the periodic functions sorted by when they're supposed to run, and is in part of the main, in part of the agent's main loop. It will check to see whether or not any periodic functions need to run, and then it will the main loop will sleep until the next periodic function becomes available. Things like scheduled events are just spawned immediately in their own greenlets, and those are not part of the main G event loop. Let's see. And in case anybody asks, yes, we could actually set up the periodic functions to run in their own individual greenlets. I'm not sure off the top of my head why Brandon did it this way. I would have to ask him next time I see him, if I remember. But that's the way that it's implemented in the main loop. I believe that when it goes to actually execute, let's see. I think when it goes to actually execute a particular method, it spawns it. No, actually, let me look. It does not spawn it in its own greenlet, which is fine. It actually doesn't matter, but what it means is that more than one, well, let's see. It means that more than one periodic method will not run at a time. Maybe that's why he did it. Yeah, I'm going to say this, but I'm not going to say it with 100% confidence. but I believe the implication is that more than one periodic methods run serially and they don't interleave. And that was probably done on purpose, but oh, no, that's incorrect. Actually, each periodic is running its own greenlet. We see that right here. Yeah, because when we call periodic, let's see, let's go back up here and look. So if we run periodic, well, there's no start method. Oh, no, the periodic is right there. Let's see, periodics is a list. Periodics extend member get. Oh, okay. So we'll have to look at the periodic method to understand exactly how that works. I think actually when we call periodic, it creates a greenlet for it. So yeah, in fact, it would have to because otherwise this line right here would not be necessary. Okay. So
yeah, Kyle, I'm just looking at the start periodics method. It looks like it just goes through each and adds it to spawned greenlets and calls start. So
yeah.
Is that where you are now, or where are you?
Yes, I'm sorry. I'm on line 217.
That's okay. Okay, thanks.
Yeah. Sorry. I'm jumping around and I'm like, should I?
Yeah, no, that's okay.
So if we jump down to line, let's see, where is it? Schedule, spawn later, spawn in threads, and stop. Oh, where is it? Periodic. Okay, so if you jump down to line 379, there's you'll see there's a dual method decorator. This is some magic that Brandon developed a long time ago. It allows you to have two methods with the same name in the same class, and it will call the right one depending on the context. In this case, it allows us to have the function periodic be both a decorator and a method, and be both a class method and an instance method, and have them do different things at the right time. So if we call it as a class method, that's what's happening when you are when you use it as a decorator, and basically it's returning. It's wrapping it in the periodic class. And then if you call the class method, it immediately puts it into a greenlet and just starts it. So the difference with the class method on line 386 is that it's basically marking that function to have it be spawned in a greenlet later on in the life cycle of the agent. So if we go back up to the setup function and we look at start periodics is immediately connected to the onStart event, so that if you decorate something as a periodic function and you do like an RPC call in that periodic function, this ensures that the periodic function will not get called until you're actually connected to the message bus. A common mistake for an agent developer is to try and do RPC calls like in their constructor, or try and publish something, or usually the most common mistake is to try and do a subscription in the constructor or in an onSetup method, and you're not guaranteed to be connected to the message bus by the time your code runs. But we want you to be able to like publish something or do an RPC call in a periodic function, even if you set it up using the decorator, and this ensures that case. So line 217 to 223, we're saying wait until you hit the on start event. Wait until that gets triggered before you actually start up all the periodics that were hooked up via the decorator. So if we move down to line 225, you'll see that there's this loop that has a bunch of yield statements in it. So we need to remember that we are in the basic core. Now the difference between the basic core, agent basic core, and the normal core is that the basic core never actually connects to the platform. Then the obvious question is, well, why would you ever want an agent that doesn't connect to the platform? This is good for child agents that have that need child agents. Basically, an agent can have another agent running inside of its own process, and this is useful for when you need something that has to deal with an entire agent lifecycle, but doesn't necessarily need its own private connection to the platform. The use case for this, and needs all of the other features of the agent, like being able to create periodics, being able to schedule things on its own and manage its own schedule, and do that independent from the parent agent. We use this in the master driver agent. Every driver configuration that you set up causes the master driver to spawn a child agent that is a basic agent. It does not maintain its own connection to the platform. If it did, you would actually it's easy to run out of file descriptors on your operating system, because if they were full-fledged agents, each one would open up like four I think it's 4 file descriptors, and if you have you will run out of file descriptors at something like 200 to 300 devices. And so to work around that problem, we broke many of the key components of an agent out into the basic core, and so you can have an agent with a complete life cycle that has a setup, has a start, has its own scheduling, has its own periodics, has its own set of greenlets, and but is not actually connected to the platform. And then for things that actually do need to talk to the platform, in the example of the master driver, we pass a reference to the parent agent's VIP object, so then the child agent can use it to do its platform communication if it needs to. The backnet, that's how the backnet driver communicates with the backnet proxy, is it uses the master driver's VIP object to actually do the platform communication. So then the master driver only ends up opening 4 or 6 file descriptors to connect to the platform, and it just stays at that amount. There are potentially other uses for this, but that's the one that immediately comes to mind, and that's just really, I think it's the only place that we're actually using it. So this loop is defined, represent each of those yield statements represents different steps in the agent lifecycle. When we look at the fully fledged agent here in a minute, we'll see that loop is actually fully defined, and there are still yield statements in there, but those yield statements happen after we have confirmation that things have happened, so that we can declare, okay, our agent has reached this point in its life cycle. Now we can proceed to the next part, and we do it through this yield loop. So the main, let's see, I'm going to gloss over link receiver. This has to do with this is part of the machinery for connecting up when we use the decorators, connecting them up at agent start. Like for instance, setting up subscriptions in using the decorator and stuff like that uses link receiver. Okay, so the main run method, this is the method that actually is the main entry point for running the agent, as it says in our comment. When you look at in the code for VIP main that you pass the instance of your agent into, it ultimately is starting the run method in a greenlit. So we within here we define several helper functions that are only used in this run method. So you have kill leftover greenlets, which goes through and kills all of our greenlets that are in spawn greenlets. We are going to so we get the current greenlet, so the greenlet that we're actually running in, so that we have a reference to it, and then we use that to hook up the kill leftover greenlets to the when our main greenlet exits, we run this function. Let's see.
Hey, Kyle, what's the purpose of this self greenlet equals current equals gevent.getCurrent? So
gevent.getCurrent gives you a reference to the greenlet that you are currently running in.
Yeah.
Okay, so self.greenlet is just a reference so that we can get it at it from other functions, and then current is so we can reference it in the current function. It's kind of it's a little bit of an optimization. So when you do a reference like self dot something, it has to unlike a compiled language, which can basically
so you're trying to avoid a get adder basically.
Yeah, because it has to call it's basically calling get adder every time you do self dot something, and I mean it's obviously they've optimized it, but in code that needs to be in Python code that needs to be really, and I'm going to use air quotes here that you're not going to be able to see, performant. This is common practice, and so you'll see like in the Kivy library, if you actually look at the code for its core methods that are running in really tight loops, they'll do this kind of thing all over the place to help it out every little bit they can.
Okay.
Sometimes they get a little overboard and makes their code difficult to read. So that's why they're doing it. And it's when Brandon wrote this, he might have done it just to save himself a little bit of typing. So yeah.
Okay,
and
thanks.
I think we referenced the current greenlit a few times in here. Okay, so this run method is the agent lifecycle. When this run method exits, the agent is finished running. Now, and so just so we understand that. So if we go down, there's the schedule loop, which handles let's see, gevent get current schedule loop. Schedule event. Okay, so the schedule loop handles schedule events. If you look down on line 274, the heap that I mentioned previously that it pushes things onto to figure out when things are supposed to run, that is handled in the schedule event. That is handled in the schedule loop. So we'll see the schedule loop get created here a little bit later. Oh, and one thing that I did gloss over is if you look at line 2, back at line 240, where in the signature for the run method, there's also a running event argument. This event can optionally be passed in to the run method, and when the run method gets to a certain point in the agent lifecycle, it will just trigger that event. So when you see us using agents in a script, you'll see us create a event, and then when we call gevent start, or whatever the method is in gevent to actually start the run method in the gevent loop, we'll pass that event that we get in as an argument for run, and then we'll wait until that event is triggered. And what we're doing is we're waiting for this run method to get to a certain point in its startup, which is after the agent has finished connecting to the platform. And so then we could just basically we're just basically telling it sleep and then wake us up once you're connected to the platform. That's what running event is for. We can look at that, and there are lots of examples of that in our code, especially if you look in the script.
What's an example, Kyle?
Okay, so
I kind of understood what you said, but I definitely want to look at an example.
Okay, look, I'm going to, because I know where one is right off the top of my head. We're going to go into the scripts directory, and we're going to go to install master driver configs. And if you go into install master driver configs, line 102, you'll see that we create an agent, but because we don't call utils VIP main on this agent object, we need to start it by hand. On line 106, we create a gevent event, and then in line 107, we call spawn. Gevent spawn, we call it on the agent's core on its run method, and then we pass the event in, and then when it gets to that spot in the core run method, the event is triggered, and then our code resumes. So, yeah, anytime you need to use an agent as part of a script, basically from line 102 to 108, that's your boilerplate right there for doing that. And even a bunch of stuff like you don't necessarily have to specify an identity for that agent if you just want it to be anonymous. You just leave the identity out, and then after the event returns, you have an agent that you can just start doing RPC calls with. So useful for scripting some sort of interaction with the message bus. So so back in core, let's see. Okay. I'm not going to get bogged down in all of the events that are created, mostly because I'd have to do some digging to remember exactly how they work, so I don't want to say something that's incorrect. So we create our looper object. Let's see, where's running event? Oh yeah, running event was our argument going in. So if we look at loop, loop takes the running event as an argument. So loop because loop has yield statements in it, that makes loop what's called a generator. And a generator is a type of iterator that just produces values and then maintains state. So you could write a function that has more than one yield statement in it, and then you could do for x in, and then instantiate that function, and the object that it returns is something that you could step over. And then so in your for loop, every time your for loop executes, it will run your generator function until it hits a yield statement. It will return that value and maintain state, and then on your next loop, it'll continue where it left off until it hits the next yield. So in this, basically, we're doing in our loop method, we're doing in the basic core, we're doing it's basically no ops, and we do a little bit of magic in here because normally you would on line 285, normally you would take this looper returned by the loop function call and run like a for loop over that, and that would give you the return values for all the yields. In this case, we're using the looper to just execute to a certain point in a function and then stop. So when we call next, next is part of the iterator interface. So we're circumventing, we're using the iterator directly instead of through a for loop. So looper, we call next on looper, and that says run until you hit your first yield statement, and then return that whatever yield yields. In this case, it always yields. It's yielding with no argument, so it's returning none. And so we just call next and say run to that point. And then once we hit the first yield statement, the looper stops, and then we say, okay, we're done with on setup. Now in basic config, on setup in our main loop, in that looper function, nothing happens, which is what makes the basic core basic, is that loop function is not actually doing anything. So it's not connecting to the platform, it's not doing any of the pre-setup stuff. So we tell loopers, like, okay, go to your first yield statement, then we're going to fire all the on setup methods. Then we're going to we're going to fire again, and we're going to go to the next yield statement. And this time we're actually going to get the return value. In basic core, this is none. So if loop, actually we could say if loop is not none, but none evaluates default. So in our basic core, this evaluates default. So we don't add this to our list of spawn greenlets. So what this is telling us is that on our second yield statement could actually yield a greenlet. And so when we look at the main core, we'll see that. Let's see. So then we start our schedule loop in its own greenlet and add it to the scheduler. If we,
Kyle?
Yeah.
One question. I'm just curious. Is there a technical reason for implementing the loop, or I mean, would an alternative have been to just have different methods that pre-setup, post-setup, or whatever the appropriate method names would be, and then have those overridden?
Okay, so that is a good question for Brandon.
Okay.
And it's, I mean, the first time I looked at that and like I was scratching my head and like, and then I thought about it, I was like, well, it works, so I'm not going to get bogged down in it. But yeah, you could certainly write it like that. Like instead of this looper object, we could have had 4 methods, and those methods could have been empty or just returned none, or just return none, and then you would do that. So
okay, I just wondered if there was some like subtle G-event related thing.
No, it is not a G-event thing.
Yeah, okay.
G-event doesn't have any special sauce for generators, unless it's actually I take that back. G-event does not treat generators any differently. It's just code to get executed. It might use generators, and there might be a fancy way that you can use a generator to tell G-event to do something, but it's just code.
Okay.
Yeah. So you could certainly have written it like that, and in full disclosure, if I had written it, I probably would have written it that way. But that's my personal preference. You'll see Brandon's code is known for Brandon is very well versed in very concise ways of doing things in Python, and so sometimes you'll see something and it just wouldn't have ever dawned on you to solve a particular problem like that, and that's just a testament to his skill level and his preference in coding style. And I don't mean that as a slight in any way. It's just that's the way Brandon programs, and he's very talented and he's very good. That's that. None of this is meant to be like a backhanded comment. Well, if I had done it, I would have done this. No, it's just he's very good, and that's you see a lot of stuff that you're like, oh, I never would have thought to do it like that. So
I think that the looping makes sense as long as you know about the subclass implementing loop. But when you first see loop without having read ahead to the subclass, it's really confused. It's like, what?
Yeah, yes, yeah, exactly. So, let's see.
But yeah, it all makes sense. Thank you.
Yeah, yeah. So, we have a delay on start signal, which I'm trying, let's see. I need to remember what that is and why we do it.
So I think I know why we have those.
Yes, remind me.
So the auth agent especially, was the encryption stuff. It's all implemented as an agent, so it has to be able to start before like the main router starts.
Right. Yeah. So yes, that's correct. And on start does not fire cannot start until the router has started. And so this allows agents, and it's for core agents that are actually built into the VOLTTRON executable itself, not like stuff in services core, but like what Mike mentioned, the authorization agent. Those agents have to do a certain amount of work, including calling on their on-start methods that are there's things that they need to do on start, but they also need to start up before the router starts, and so we intentionally delay the on-start signal until after the router has started, so that we basically spread the startup. I think it's, and correct me if I'm wrong, Mike, I think we spread out the startup process of the authorization agent to part of it happens before the router starts, and then the rest of it happens after the router starts. Is that correct?
Yeah, that sounds about right.
Yeah, that's okay. Yeah. I think we might use it. I think we were thinking about using it in the config store too, but I don't think we actually had to. But that's something else that might have to benefit from it eventually. Okay. So if we're not delaying our on start signal, then we go ahead and call all of the on start methods. So, and that's the important thing is when this second call to loop returns, if we're in the full blown agent core, this line does not execute until we've actually established a connection to the platform, and so then we can call our on start methods, and then and then we also have, let's see, did I go too far? Let's see, delay running event set. And then delay running event set is so we can tell this agent, okay, if you delayed, now go ahead and do what you were going to do. So let's see. So that this from line 295 to 299 is how we do the delayed on start. Okay. So then the main loop, of the function is in line 301. So if loop and loop in gevent wait count 1. So there's actually a lot going on in line 301. So if loop means that if we are running in this is how it determines whether or not we're running in the full agent core or if we're running in the basic core. If this is false, and this is Brandon leveraging the how the looper works, or yeah, it's the short version is we're waiting. Um, this starts. Okay, I gotta make sure I gotta make sure I'm reading this correctly. Okay, so we have next, 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 and next. So um, okay, so we're connected to the platform. Oh, right. This just basically puts the agent to sleep. Yeah, that's what this is. Okay, so this puts the agent to this main G event or greenlet, basically just stops it. And so everything that happens from here on out is periodics, responses to responses to uh, or scheduled events, uh, responses to RPC methods getting called, um, callbacks for pub subs getting called. So basically, it's saying block here until this returns. And then this is just basically checking for an error state. And I believe it's and this is if if we are in the fully fledged agent, and that part of the loop blocks until or yields when we don't expect it to, raise a runtime error. So if we look in, so if we go in and we look in the main loop, we'll see that there's basically after it creates the connection, it gets to a point and it just stops. So to get back to this actually makes me think. So I think part of the reason that Brandon used this looper construct is if you go in to when we go and look at the fully form the full core loop method, it's so that the different parts of the life cycle of the agent just are all in line, one right after the other. And so it's, you don't have to dig around look for different functions. It's just all right there in one logical progression of the agent life cycle. Okay. So when this when this wait returns, then we will go down and we'll call stop wait, and then we'll call scheduler kill, which kills our scheduler. Progress to the next phase of our life cycle. Call all of the on stop method. Wait for all of the on stop methods to finish calling. Go to the next part of the loop life cycle, and then call all of the on finish methods. So this is the outermost generic logic for an agent. But the key thing to take away from this is that you've got different phases of your life cycle. You've got your on stop, on finish, on setup, and on start. Okay. And then there's a stop method which calls let's see, gets the main greenlet, and it sends the stop event. Let's see. So let's see where stop is defined here. I think stop is the stop event. Yeah, right there. So we have this stop event, and so this will wait until the stop event will trigger, and if we call stop on the agent, it triggers this stop event, which causes this to drop out. and then once that drops out, then it goes through. So one of the things that happens there's an on-stop method that's set up, because there's an on-stop method that's set up by the core agent that, like, for instance, goes through and cleans out all your greenlets, all your currently running greenlets. Let's see. Send is used to do well. The primary use for it is hooking up events. Let's see. Send async. Okay, so we're on line 327. For those of you who can't see the desktop. So send async is for doing. Let's see, worker. Result. I'd have to, I'd have to look and see how this is used to remember how in project. I don't see any uses of it. Oh, here we are. Okay. So this does, this allows, this sends a, this calls the halt, sends the halt method to be run at a later time. Let's see. So receiver. Let's see, async. Oh, I'd have to stare at this for a while to remember what this is for, but it's part of we use it for lifecycle handling, and there's probably a reason that we need to do it this way. I don't remember off the top of my head. Okay, so now we get down into the utility functions that are part of core in line 352. We have spawn and spawn later. So instead of calling g-event spawn yourself in your code, which you can do it if you know what you're doing, but it's recommended that you call our spawn method instead, which is a wrapper for g-event spawn. And then if once you've called spawn, it will add, in addition to spawning the greenlet, it adds it to the list of spawned greenlets so that it can be shut down properly if the agent gets shut down. Same thing with spawn later. It's just a g-event wrapper for spawn later. That does the same thing, except that you can specify the number of seconds before the greenlet happens. Spawn in thread. This creates a thread around your function. And the only restriction to spawn and thread is that you should not spawn new agents in your function. And I don't think you should do RPC calls either, or anything that uses the agent core. So if you if you want to do something in a different thread that will block, for instance, you've got a library that blocks on I/O and you can't figure out a good way to get it to run cooperatively, you can call spawn in thread, and it will spawn a new thread which will not block your main g-event loop when it blocks for I/O. And it will set up an asynchronous result, which is the bridge between threads and the g-event loop. And then an asynchronous result is like when you do an RPC call, the actual thing, your return value is an async result, and then you call get on it, usually with a timeout, to get your result back. This works exactly the same way, except that instead of the RPC machinery happening in g-event, it's whatever you're doing is happening in another thread. And so you can do something that needs to block for, you can call a function that needs to block on I/O for a long period of time, and it won't block your main G event loop. And then it can return something, and then you can just call get on the result and get the result, whatever your get the result of whatever your function returns. It's just that the only rule is if you use spawn and thread, don't use any of the agent core facilities like RPC calls or publishing or anything like that, because we have not done anything to ensure that core is thread safe. So, you just pair your core, your spawn and thread down to the thing that actually needs to block, that is not cooperative, and get the results, and then do everything like your RPC calls and stuff outside of that. Periodic. So let's see. So 379, that's the periodic that you're usually going to care about. So this is that on 379. That's the periodic that you would call if you wanted to dynamically set up a periodic function. So you would set the period in seconds, the function that you want to call, any arguments or keyword arguments that need to get passed into the function, and then the wait is how long to wait before the first time you call. And I believe if you leave wait off, I think it gets called immediately. I'd have to look. So we create a oh, that's right. Periodic returns. You call get on periodic, and you get the greenlit back. That actually, that's how it works. Okay, yeah. So all periodics are run in greenlets. So you pass. You create your periodic class. You call get with your function, and you never use periodic directly, but this returns the greenlet that gets created from your periodic. Receiver is used in core. I'd have to do some digging to remember how it works and what we use it for, so we're not going to get bogged down in it. Schedule's a single call of a function sometime in the future, based on the deadline, and the deadline is let's see, I believe it's the timestamp. Let me look this up. Yeah, you give it a timestamp, a date time object, and for when you want the scheduled method to run, and then we do the right thing and we stick it in the heap so the scheduler will run it later. So if you want to schedule something to run just once, you want to tell it how far into the future based on a date time object you just call schedule, and it'll do it for you. If you don't want to figure out, so the difference between schedule and spawn later is spawn later takes a number of seconds. So I want this to run 15 seconds in the future. Schedule says, here's the date time that I want you to run, go. And then you don't have to worry about doing the math to figure out how many seconds that is for calling spawn later. Okay, so now we're down on line 418. We start looking at the actual core. Yeah.
I got to take off at 12:30. What were you planning? Were you planning to just keep going?
Yeah.
Okay.
This is it's there's a lot to it.
No, I know. I was going to suggest maybe a part 2, but
what do you think, Jeremy? Should we do part 2 after Christmas, or should I just keep going so we do it all in one big long lump?
Well,
I'm fine either way.
I'm fine either way. What about other people on the call?
Well, and here's what I was going to suggest, that I think at Keysensum anyway, we probably can. We've been taking notes, and I'm thinking we're going to regroup and go through this again, and then look at core, and then probably
You'll have questions for me.
have questions that we can come up with, and then you can do a walkthrough, and we can ask you better questions now with this understanding of basic core.
Would you email me your questions? Because
Sure.
like I say, there's a few things that I kind of glossed over because I'm like, oh yeah, at one point I knew how that worked, and I'm gonna have to do some reading to remember. So if I could have a chance to just if you could shoot that to me in an email, that I'll be better prepared for the next meeting.
Sure.
Yeah, so I think that's fair. Let's do a part 2 with people getting a chance to digest this, and I don't know if we'll be able to post this next week or not, but
Okay. Hey, it says that I'm no longer presenting. Did that just barely happen?
I don't see any presentation anymore.
Okay, that just barely happened. Okay, I was, I was like, if it went away and nobody said anything, I was going to be, well, disappointed. Okay. Let's see. I don't see anything yet. Yeah, it just okay. So it just barely errored out. All right. Okay. Yeah, we could do that. I'm going to. Are there any other questions? Because I was going to stop the recording, then we could discuss the logistics of the next meeting.
Quick question. My audio flaked out at one moment. What was it that you were saying about receiver?
Oh, not much. That's something I'm going to have to go look at. It has to do with hooking up different things in the agent at startup. I don't think you ever use it directly. Because
okay, thanks.
Yeah, there's a bunch of, we haven't even gotten to like the subsystems yet, and I believe receiver is used by the subsystems to hook things into core so that those subsystems can do different things at startup. For instance, the pub subsystem has to chat with has to talk to the pub sub agent at startup, and it uses I think on receiver is used to hook things up to happen later during its startup process, but I'd have to look.
Okay, thank you.
Yeah. Sorry, I don't have the answer right now. I'll have to look. All right. Are there any other questions? Okay.
All right. Well, thanks everybody.
All right. I'm going to turn it